Alright, so now let's look at oxidation of alcohols. Okay. And we're going to start with oxidation of primary alcohols. And the oxidation reactions will be different for primary, secondary, and tertiary. Okay. So now this is where this oxidation reactions are where we start to distinguish between the chemical properties of primary, secondary, and tertiary alcohols. Okay. For the nucleophilic substitution reactions, they were the same. Any nucleophile will substitute for an OH group. Doesn't matter if it was secondary, primary, or primary, secondary, or tertiary. Okay. So now let's look at an example of a. Let's start with an example of a primary alcohol. Let's say that we have something like propan-1-ol. Okay. A primary alcohol has this characteristic group, right? CH2OH. And what I can do is I can react this, okay. I can use over here. There's a few different oxidizing agents I can use. The first oxidizing agent I can use is acidified KMnO4 minus, right? The other oxidizing agent I can use over here is, anyone remember the other oxidizing agent I can use? I can use this, or I can use acidified potassium dichromate, right? Cr2O7. That's the dichromate 6 ion, right? Again, it doesn't matter if you say KMnO4 or you say MnO4 minus, and it doesn't matter if you say Cr2O7 2 minus or you say K2Cr2O7. Okay, they're the same thing, because it's the cations here are spectators. It's the anions that are the oxidizing agents here. Okay. And sometimes they'll even say potassium. Sometimes they'll even give you sodium dichromate. It's the same thing though. The dichromate ion is present, right? So what we have here is, if we heat this under reflux, okay. Now in this case you have to say heat under reflux, okay. In other reactions they may accept heat as well. They will accept heat as well. But in this particular reaction you have to say heat under reflux, and I'll tell you why, okay. And what you're going to end up making over here is, carboxylic acid, okay. And the equation for this reaction looks like this. You have a primary alcohol, okay, and you have the oxidizing agent. So the oxygens from the oxidizing agent can be represented as O from a square bracket. So this over here represents the oxygen from the oxidizing agent. Okay, and what you end up making over here is, you end up making CH3, CH2, CO2H, okay, and you make H2O. Over here, the observation for this reaction is that if you were using potassium manganate 7, right? If you were using potassium manganate 7 over here, then your observation would be purple to colorless, okay. Okay. And if you were using potassium dichromate 6, okay, this is KMnO4, okay, and this is Cr2O7 K2, right? If you were using potassium dichromate 6, then your observation would be orange to green. It's an orange solution that when it undergoes reduction, when it oxidizes something, it turns green. Okay? So these would be your observations depending on which oxidizing agent you used. Okay, so in this reaction, okay, in the first stage of the reaction, the primary alcohol, okay, is first oxidized to an aldehyde, okay, and then in the second reaction, this alcohol as this aldehyde, sorry, is oxidized to a carboxylic acid. Okay, it's oxidized to a carboxylic acid. So it's this group that's being oxidized, obviously. CH2OH is first oxidized to a CHO, and then the CHO is oxidized to a CO2H. Now, if I heat under reflux, what I'm doing is I'm allowing the oxidation to take place all the way. So I'm allowing completion of the reaction, okay, which means that carboxylic acid will be produced, right? Because heat under reflux means that the reaction will keep on happening until you reach the final oxidation product, which is the carboxylic acid. And I'll show that to you over here, okay, how that works in just a second. But my question is, what if I wanted the aldehyde in this reaction? What if I didn't? What if my desired product was the aldehyde and not the carboxylic acid? What would I do then? So the idea here is this, okay? What we have is this is when we heat under reflux. As I mentioned, right? What this does is the reaction is taking place over here. As the reaction is taking place over here, right? Anytime the reactants try to boil out or anything, the condenser cools them back down. This is called a reflux condenser. Okay? This is called a reflux condenser, and this ensures that the reaction goes to completion all the way to formation of carboxylic acid. Right? Again, why does it ensure that the reaction goes to completion? Because reactants can't really boil out, okay, and they condense back into the flask because of the condenser, and the reaction takes place to the end. On the other hand, what we know is that carboxylic acids and alcohols can hydrogen bond आपस में with each other, but carboxylic acids show hydrogen bonding because they have an oxygen directly bonded to a hydrogen atom, and alcohols also show hydrogen bonding because they have an oxygen atom directly bonded to a hydrogen. Okay. On the other hand, aldehydes do not hydrogen bond with other aldehydes, so they have lower boiling points. They have lower boiling points than alcohols and carboxylic acids. So what we can do over here is that if we use something like potassium dichromate, let's say, right, and we heat and distill off the product, if we heat and distill off the product, right. So over here, if I asked you what are the conditions for formation of aldehyde, you will say you'd acidified dichromate and heat and distill. You will not say heat under reflux, because heating under reflux will give you a carboxylic acid. Okay, and then if you just take this, so over here the aldehyde, when the reaction is taking place over here, right, as the aldehyde is being produced, we'll keep the temperature such that it's below the boiling point of acid and alcohol, but it's above the boiling point of aldehyde. So this will ensure that the aldehyde evaporates, okay, as it's being produced. As it's being produced, it boils and is separated through distillation. Okay, that's how we obtain the aldehyde separately. So again, because the aldehyde has a lower boiling point, okay, you can produce it by heating the reaction at a temperature that's below the boiling point of the acid and the alcohol, right, and above the boiling point of the aldehyde, and you'll be able to obtain the aldehyde will boil, and you'll be able to obtain it through distillation. Okay, and if you allow this reaction to go to completion, what do you end up getting? Right. Ultimately, the aldehyde will also be converted to what? Carboxylic acid if you heat the aldehyde under reflux. Okay. So you can go directly from primary alcohol to carboxylic acid by heating under reflux. Okay. You can start with an aldehyde and go to carboxylic acid by heating under reflux. But if you start with a primary alcohol and you don't want an acid, you want an aldehyde, you will heat and distill off the product. Okay. Another thing to note here, guys, is this. Okay. for the first reaction, when you're heating and distilling the product, okay, you can use acidified KMnO4 as well. Okay, and now they accept it. Previously they didn't accept KMnO4, but now they accept it. But it's dichromate is a better reagent for this part. Okay, for this part over here, dichromate is a better reagent. And the reason why is because dichromate is a weaker oxidizing agent than manganate. What that means is that over here, if the alcohol is reacting with the oxidizing agent, it's being converted to aldehyde and the aldehyde is being converted to acid. Now, if you're using a stronger oxidizing agent like manganate, that conversion will happen faster. So, जैसे जैसे aldehyde बन रहा है वो क्या बन रहा है फिर aldehyde react करके acid बन रहा है. If you use a weaker oxidizing agent, lesser of the aldehyde will convert to acid because it'll take more time, right? Weaker oxidizing agent means that the aldehyde has more time to escape before it's converted into an acid. So it's better to use dichromate for this reaction, especially for the heating and distilling of the product. Okay. So that's why whenever you see me write it, I'll always write dichromate from primary alcohols to aldehydes. Whenever you're heating under reflux, it doesn't matter. You can use manganate or you can use dichromate, right? So in this example here, if you're heating the primary alcohol under reflux, you can use dichromate or manganate, doesn't matter. So for distillation, it's better to use the weaker oxidizing agent. Okay. But you can use manganate as well. Now, if you look at this reaction, right, what do we have here? You have, so again, when we're talking about the conversion of a primary alcohol to a aldehyde, okay, it's better to use dichromate, and we're going to heat and distill of the product, right? And what do we get? We end up getting this aldehyde. Okay, the CH2OH is converted to CHO, and the reaction over here is if you take the primary alcohol, okay, you are adding one oxygen atom. This is an oxidation reaction. You're oxidizing a primary alcohol to an aldehyde, and you end up with what? The aldehyde CH3, CH2, CHO, and H2O. Now there's two ways to view this. First of all, remember addition of oxygen from redox represents oxidation. So this oxygen again is from the oxidizing agent. We mentioned this before. Whenever you have an oxygen in square brackets, it means oxidizing agent is acting over here. Secondly, if you look at the actual molecule of ethanol and you see what happens to ethanol as it's converted to an aldehyde, what atoms are being removed from the ethanol molecule? So here removal of hydrogen is oxidation, right? Because the atoms being removed are hydrogen atoms. Okay. So that's reaction 1. And again, we just said that we can take an aldehyde, right? We can take an aldehyde and we can convert it into a carboxylic acid by just heating under reflux, right? You can use dichromate or manganate here. Okay. For distilling, I'll prefer dichromate, but for this you can use either, right? Heat under reflux. Okay, just like you can start with a primary alcohol or an aldehyde. If you heat under reflux, you'll end up getting a carboxylic acid with this oxidizing agent. Okay. And then the equation for this is, okay, what you have is you have this guy reacting with oxidizing agent to form CH3, CH2, CO2, H. Okay. And what do you see here? If you add 1 and 2 together, you get the equation for the oxidation of primary alcohols all the way to carboxylic acids, which we've already written down earlier, but I'll write it down again. If you add 1 and 2 together, you get CH3, CH2, CH2OH plus 2 oxygens, okay, to give you CH3, CH2, CO2H and H2O. So this is the overall equation from primary alcohol to carboxylic acid. Okay. So what you see here is that from primary alcohol to aldehyde, you're adding one oxygen, right? And you're removing two hydrogens here. You're removing two hydrogens. Then from aldehyde to acid, you're adding an oxygen, right? So if you look at the overall conversion from primary alcohol to acid, there's two oxygens over here. One is being added directly to the molecule. Molecule make oxygen बढ़ रहा है और दो hydrogen remove भी हो रहा है. Okay, and you should know all of these equations here. Okay. All right. Now, what are we going to look at next? So now if you talk about reduction of carboxylic acids and aldehydes, okay? These reactions will give you back a primary alcohol, okay? So for example, if I have, let's look at the same reagent, the same molecules that we had here. If I have, let's say, an aldehyde over here, okay, CH3, CH2, CHO, okay, what will happen is that I'm going to use the reagent I'm going to use is the reagent I'm going to use over here is, there's two reagents that you can use. One reagent is called NaBH4 aqueous, okay, NaBH4 aqueous, okay. This reagent is called sodium borohydride, okay. Sodium borohydride. So here you have sodium borohydride as your reducing agent, okay. Another reagent that you can use over here is LiAlH4, okay. But this reagent, okay, this reagent over here, okay, I'll specify this, has to be used in dry ether. Now, what do I mean by dry ether? Ether is a solvent, okay, ether is a solvent, and lithium aluminum hydride is a very strong reducing agent, and it reacts explosively with water. So if I want to reduce an aldehyde using LiAlH4, which is lithium aluminum hydride, okay, I'll write that down, lithium aluminum hydride, okay. If I want to use this reducing agent, I have to make sure that no water is present, because it will react explosively with water as well. So in order to reduce with this reducing agent, I have to use a solvent that has no water. That's what I mean by dry ether. It's a liquid solvent, but it doesn't have any moisture present, okay. So sometimes you'll also see the term anhydrous lithium aluminum hydride, okay. Anhydrous means in the absence of water, okay. And you're going to heat. Okay, you can use either of these two reagents and you're going to heat. And what are you going to end up with? You're going to end up making back a primary alcohol. Okay. Now what do you have here? What you have over here is that if you think about the equation here, right? If you remember, from primary alcohol to aldehyde, we were removing two hydrogens, right? Adding one oxygen or removing two hydrogens. For the reverse reaction, how many hydrogens do you think we're adding back now? We're adding back two hydrogens. For this reaction, for this primary alcohol to aldehyde, we wrote plus one O, right? And two hydrogens were removed from the molecule. One oxygen was essentially added in that from the oxidizing agent. In this, you're simply adding back two hydrogens, okay, to form CH3, CH2, CH2OH. This is the H from reducing agent. Okay. Now for this reaction, you can also use hydrogen and nickel. Okay. But the issue is with the issue over जिस तरह से आप alkenes के लिए use करते हो. The issue with using hydrogen and nickel is one that is very specific to Cambridge. Okay. Now what has happened in the past is that Cambridge has given a question where they have said that you have an aldehyde and you have a primary alcohol, right? Or you have an aldehyde and you're using hydrogen and nickel. What is the product? Okay. And they're like, okay, alkene को reduce करो लेकिन aldehyde को reduce नहीं करना. And then the examiner report said kids are expected to know that hydrogen and nickel will not reduce an aldehyde. फिर एक और पेपर में एग्जैक्ट उल्टी चीज़ आई है. उन्होंने एक मॉलिक्यूल में alkene और aldehyde दिया हुआ है, hydrogen and nickel react कर रहे हैं, and they're like kids are expected to know that hydrogen and nickel will reduce an aldehyde. So they're inconsistent. This is evidence from examiner reports. There are two different papers where one is saying they should know that it won't reduce it, another one which is saying they should know that it will reduce it. The fact of the matter is that it actually does work. Hydrogen and nickel does reduce aldehydes and ketones, okay? But whenever you're asked to quote the reagents and conditions, just quote these two reducing agents. But in a question, if they've given you hydrogen and nickel and a reactant, you should know that it will reduce aldehydes and ketones, okay? Because Cambridge is inconsistent, we're just going to go with the correct one, which is that it will reduce it, okay? So this is a possible reducing agent. If they've given you in a question कि भाई ये चीज़ hydrogen and nickel के साथ react कर रही है CHO, you should know कि primary alcohol group बनेगी. लेकिन आप लोग कभी reagents और conditions जब लिख रहे हो तो कभी भी hydrogen and nickel नहीं लिखना चाहिए. Hydrogen, nickel, and obviously heat, right? All right. Now you can also reduce a carboxylic acid, okay, to a primary alcohol. But for this reaction, you have to use lithium aluminum hydride, okay? Sodium borohydride will not reduce. Sodium borohydride will not reduce a carboxylic acid, okay? Lithium aluminum hydride is actually a stronger reducing agent. Okay, again, it's going to be in dry ether or anhydrous, okay? And again, you're going to heat it. And now what will you end up adding, forming? Again, you're going to end up forming a primary alcohol. You can't go from an acid to an aldehyde. जब आप reduction करोगे तो आप हमेशा वापस कहाँ पहुँच जाओगे? Primary alcohol पे, या भले आप acid से शुरू करो या aldehyde से शुरू करो. Okay? There's no middle stage in this reaction. You'll always end up either directly to the primary alcohol. And the equation for this reaction is similar. But if you guys remember, when we went from primary alcohol to acid, there were two oxygens being added. So in the reduction stage, how many hydrogens do you think are going to be added? So in this reduction reaction, 4 hydrogens will be added, okay, to form. Okay. Now what do those 4 hydrogens do? This is what happens, okay. You have the 2 hydrogens are being added to the molecule itself, right, CH2. 2 hydrogen extra यहाँ पर आ गए, and the remaining 2 hydrogens are taking away an oxygen, right. One of the oxygens from the acid is removed by the remaining 2 hydrogens. All right. So so now we've seen oxidation of primary alcohols to produce aldehydes and acids, and we've seen the reduction of acids and aldehydes to give you primary alcohols, okay. Now let's look at oxidation of secondary alcohols. Okay. When we look at oxidation of secondary alcohols, right, let's take an example. Right, and what I'm going to do here is I'm going to, again, I can use dichromate, or I can use acidified manganate. Okay, I can use acidified dichromate, or I can use acidified manganate. And I can heat under reflux. Okay. And I can also heat and distill off the product. Doesn't matter if I heat under reflux or if I heat and distill off the product. What will a secondary alcohol oxidize to? This is the secondary alcohol group that's being oxidized. These carbon atoms are unaffected. So the oxidation reaction over here simply results in the formation of a ketone. Right? Again, you can heat under reflux or you can heat and distill off the product. Even if you distill, you still get a ketone. If you heat under reflux all the way, you'll still get a ketone. Why? Because you can use distillation because ketones have a lower boiling point than the alcohol, so you can separate the ketone. If you heat under reflux all the way to completion, even then you're still producing a ketone because secondary alcohols cannot produce acids, right? There's only one reaction in which we'll study about that later, but in this particular reaction, what you're going to end up with is a ketone. Okay. So secondary alcohols are oxidized to ketones. And if you had to write the equation for this, you have CH3 CHOH, right? CH3 being oxidized to form CH3 CO CH3 and H2O. Very similar to the equation where primary alcohols were oxidized to aldehydes, right? One oxygen is being added and two hydrogens are being removed, right? So like the oxygen being added is essentially removing the two hydrogens from this compound. Again, you're not directly adding an oxygen onto the molecule. This oxygen that's coming from the oxidizing agent is removing two hydrogens from the molecule, hence we say that it is an oxidation reaction. And you can actually verify this using oxidation numbers as well. Okay, carbon ka oxidation number बढ़ जाता है, but it's an oxidation reaction. Same thing for this, the first one over here, okay? Just a clarification. Okay, the same thing over here. If you look at the primary alcohol wala reaction to an aldehyde, when this oxygen came from the oxidizing agent, two hydrogens were removed from the primary alcohol, which is basically oxidation, okay? And those oxygen basically took those two hydrogens and made water. And then aldehyde wale mein oxygen was directly added to make acid, okay? All right, now. Again, the observation here will be, you'll see orange to green with dichromate or purple to colorless with manganate, right? Now you can also reduce a ketone. Okay. And if I let's just take this ketone only. Okay, so if I take this ketone here, okay. And again I'm going to use, I can use NaBH4 aqueous, or I can use lithium aluminum hydride in dry ether, okay, LiAlH4, okay, in dry ether. Again, I'll mention this can also be referred to as tetrahydroborate because you have four hydrogens here, sodium tetrahydroborate, or sodium borohydride, okay. And again, I'm going to heat this and I'm going to end up remaking the secondary alcohol. Okay. All right. And what's the equation for this? Again, you have CH3 CO CH3, okay, reacting with, in this case there was one oxygen, the reverse reaction will have two hydrogens. All right, another note again, you can, as I mentioned before, if asked in a question, can you use hydrogen and nickel, you should say yes, okay? But if you're ever quoting the reagents, just state these two. Hydrogen and nickel again will work, okay? The last thing I want to note here is before I move on to the tertiary alcohol part is that for carboxylic acids की reduction NaBH4 भी नहीं चलता, hydrogen and nickel भी नहीं चलता, सिर्फ ये reducing agent ही use कर सकते हो, okay? Which is lithium aluminum hydride, all right? Now tertiary alcohols, okay? Tertiary alcohols do not undergo oxidation, okay? Do not get oxidized, period. Okay, they do not get oxidized. Okay. So if you had something like this, okay, if you had something like this and you treated this with acidified dichromate, for example, or you treated this with acidified manganate, okay, and you heat it under reflux, okay, you will get no reaction. So the observation here would be no color change. अगर dichromate use करो, solution will stay orange. अगर manganate use करो, solution will stay purple, because this tertiary alcohols don't get oxidized, because if you notice, again, remember, the carbon atoms don't get affected. The carbon-carbon bonds don't get affected by these oxidation reactions. So the COH, there is essentially no space for oxidation to take place in a tertiary alcohol, okay? The tertiary alcohols do not get oxidized. Again, for primary alcohols, you get aldehyde or acid, depending on whether you distill or reflux, because terminal carbon पे होती है primary alcohol. Secondary alcohol, you get a ketone if you oxidize it, okay? And tertiary alcohol does not undergo oxidation, okay? Now let's say that I have a compound like this. So let's say that I have a compound like this, okay? And I have this guy here, okay? And what I do is I take this compound here, and I react it with, first I take it and I react with acidified dichromate, okay, and I heat under reflux. Okay, I heat it under reflux. Now, this group over here, what will this form if I heat it under reflux? What is this kind? What kind of a compound is this? This carbon atom. What kind of a group is on this carbon atom? It is a primary alcohol. So primary alcohol क्या बनाएगा when you heat it under reflux with an oxidizing agent, dichromate? You will make under reflux. You will make a carboxylic acid. And what about this carbon here? What kind of an alcohol is this? Secondary alcohol. Okay, so you won't say there's two alcohol groups here. You will say there's a primary alcohol functional group here and a secondary alcohol. The secondary alcohol will end up making a ketone. Okay. So again, the primary alcohol here ends up making the carboxylic acid. Okay, and the secondary alcohol here ends up making the ketone. Okay, so this is your product. Okay. On the other hand, if I took the same oxidizing agent and I heated and distilled off the product, I heat and distill the product, okay? Or you can just say heat and distill. What do I produce here? What will I produce for the primary alcohol? If I'm distilling, I will produce the aldehyde. And what about the secondary alcohol? I still produce the ketone, okay? So ketone can be formed whether I heat under reflux or I distill. I will always produce a ketone. Ketones won't be further oxidized. There's only one reaction in our syllabus where ketones can be oxidized. We'll look at that in the next class. But otherwise, in most reactions, ketones will not undergo oxidation further. So dichromate, manganate के साथ ketones cannot be further oxidized. So secondary alcohol सिर्फ ketone ही बनाते हैं, reflux हो गया distill हो. Whereas primary alcohol under reflux will make an acid group, and when you heat and distill off the product, it will make an aldehyde group. So make this distinction. It doesn't have to be a compound only has one type of alcohol. It can also have different types of alcohol functional groups. So if I said which types of like functional groups are present here, you would say primary alcohol and secondary alcohol. You wouldn't say alcohol.